Hey everybody, it's been a while since we did a YouTube video of a lab. We started the year much this way and we're going to end it with one of our last labs. This is the sequence of events lab, also known as relative dating. We learned about this in class on Friday, and today we are going to be doing this lab, like I said, via YouTube. This is lab number 36. It is your second to last lab. So at the very top, after you're done filling out your name and the date that you're doing this, definitely write in this blank area that this is lab 36, sequence of events. Okay, so here we go. Earth is estimated to have formed about 5.5 billion years ago. Geologists locate, observe, and interpret the clues recorded in Earth's rocks. A primary role of a geologist is to take the evidence from those rocks and reconstruct a sequence, or an order, if you will, of the geologic events. There are several fundamental principles that guide geologists in interpreting the Earth's history. Check the four laws below. Stratigraphy is the study of the history of the Earth's crust, particularly in its stratified rock layers. So when we look at this block diagram to the right, or any of the block diagrams that we're going to be doing today, we look at the rock layers, otherwise known as rock strata. And stratigraphy is studying those rock layers or strata to really figure out the relationship of the age of the rocks, as it says here. So stratigraphy is concerned with determining the age relationships of rocks as well as their distribution in space and time. Rocks may be studied in an outcrop, exposed rocks at river gorges, or a road cut, but commonly are studied from drilling rock cores. Most of the Earth's surface is covered with these sedimentary rocks that record much of the geologic history. This is what makes stratigraphy important. Sediments, such as those at the bottom of oceans or lakes and oceans, are usually deposited in layers. When layers are tilted, it is assumed that these layers are deposited level and that the area tilted after it turned into sedimentary rock. Several tools that help us to decipher the sequence of geologic events are explained below. Now, I'm not going to go through the four laws of stratigraphy. We did learn about these on Friday. They are also in your notes from this unit. Nor am I going to go through unconformity or contact metamorphism, as this would be slightly redundant. But I am going to tell you that if you get out your earth science reference tables right now, if you don't have it out, pause this video, definitely get out your earth science reference tables, as you're going to be using mainly pages 8 and 9, some of pages 6 and 7 to most certainly help you with this lab. So to do this lab, you are going to need the report sheet here. But what you're mostly going to be using, which you all received a copy of, but if you didn't receive a copy of this, you should all be obviously using the different block diagrams or these cross sections for each question that we're going to be doing. So we're going to start with this block diagram number 1. And the information that they ask about this is obviously where it says diagram 1 here. So I'll probably be doing a lot more explaining on the block diagrams as we go. I'll definitely address these questions, but I might not be flipping back and forth to your report sheet. So it might be easier, like I said, if you take this report sheet, kind of have it up in one of your browsers, or if you have the hard copy in front of you, and just be listening and following along as I show you each cross section. Okay, so here we go. This is cross section number 1. And you can clearly see from the law of horizontality that all the layers they originally were deposited horizontal, but they have been disturbed, or you can say deformed, in a way with something that makes them look curved or warped. And this curved warp look is something that we call folding, which you have learned about. Now, in the first question, okay, if we come back here, it says, what type of deformation has occurred? Obviously, we just got done saying that that is called folding. So number 1, you're going to write in folding, right? And then letter B, it says, what is the name of the rock that was deposited first? Okay, according to our law of superposition, the rock that was deposited first is this rock down at the bottom. And they want a specific name for it. And the way you get the names for these rocks, like according to what they look like in here, is you're going to go to your earth science reference tables, page 6 and 7. So I'm going to scroll along here. And that particular bottom layer in here with the lines that I'm showing you with the cursor right now, that matches with shale. So shale would be the rock that's oldest. So I'm going to go back to my report sheet. I will write in that shale is my oldest rock here. Okay, and then diagram 1C, what is the name of the rock that was most recently deposited? Well, the most recently deposited rock is this one at the top. Remember, top layers are the youngest, right? And these little like dots would match with my earth science reference tables with right here. The dots match with sandstone. So back to my report sheet I go. And in question number or letter C for diagram number 1, we're going to write in sandstone. So that's just an example of how we're going to do this today. I am not, like I'm going to say, going to flip back and forth. Every question will be addressed, but I'm going to stick with the cross sections at this point. You guys will have to fill it in on your report sheets. Okay, so I'm going to jump back here and let's go to report sheet, or I'm sorry, block diagram number 2. And block diagram number 2, letter A says what type of deformation has occurred. These rock layers have been disturbed by something we call tilting. So number 2A would be tilting. There's also a fault which runs through here. You could say tilting with some faulting, but mainly these are all tilted layers. That's what I'm looking for. So diagram number 2 now, letter B. What is the name of the rock that was deposited first? So the first rock to be deposited is always the one that's basically going to be deepest or lowest. And if you guys look here, the deepest, lowest rock, right? On this side, it goes shale, limestone, I'm sorry, sandstone, limestone, sandstone, shale, right? But on this side, it goes sandstone, limestone, sandstone, shale. There's an additional layer of limestone. So you don't get to see that here because perhaps this is submerged and this is emerged and gone up. But the oldest one would be this layer in here, which would be limestone. So number 2B, limestone. Let's go on to diagram 2, letter C. It says, what is the name of the rock that was deposited most recently? And most recently is obviously going to be what's on the top. And no matter if you look on this side or you look on this side, the top layer is going to be sandstone. So again, number 2C, your most recently or youngest deposited layer is going to be sandstone. Okay, let's go on to number 3. So diagram number 3. Diagram number 3 says, what processes, this is letter A, what processes have caused parts of these layers to be removed? So you can see all along the top here, it looks like some of these layers have been completely destroyed or kind of like wiped out and scrubbed away, if you will, by natural processes of the earth. And they want to know what does that. And this has all been caused by weathering and erosion. So weathering is the breakdown of rock. And the fact that it's no longer sitting there and carried into new locations is erosion. So again, that's weathering and erosion. That's number 3A. Okay, letter B, it says list the rocks by letter in order from oldest to youngest. Obviously, D is going to be your oldest, and then C, B, and of course, A. All right, and then diagram number 3, last question, letter C. Why would the surface of these rocks not be considered an unconformity? So an unconformity is when layers of the earth have been somehow destroyed, they have been weathered and eroded, but what makes it different than weathering and erosion, what makes it an unconformity is that a new layer would have had to bury that surface which is eroded. So like if we kind of fast forward into perhaps another diagram here like this one which clearly marks the unconformity, this used to be at the surface and was weathered and eroded, but once it got buried by the sandstone layer here, that's what made it an unconformity, which is different than just weathering and erosion at the surface. So again, diagram number 3, or letter 3C, number and letter 3C, this is not an unconformity simply because it has not been buried by an additional layer yet. Okay, so let's go on to diagram 4. Diagram 4. What is the name of this surface feature? And this surface feature, right, we obviously see some folding has taken place in here, but what's happened is you have a little bit of like a dome of a mountain being exposed through some type of like breakdown, some erosion. But again, you could say that there's folding at the surface with just like a dome of erosion which has taken place around that fold. So folding with a mountain dome, say that, okay? Diagram number 4, letter B. Did the igneous intrusion, Okay, the rock with the letter like looks like little V's. So they're talking about this layer all in here. So let me get my highlighter if I can. Ah, come on. Here's my highlighter. So they're talking about this layer all in here with the V's. And they said, did the igneous intrusion come before or after the layers above it? And I'm going to say that this igneous intrusion, okay, most likely came before, okay, any of the layers above it, like the sandstone or the shale in here were deposited. It came before because well, something I showed you on Friday is that whenever magma comes in after layers that were there should be these little burn marks, which we call contact metamorphism. So imagine this is all hot magma. If the magma had come after the sandstone, again, as it came up, it should have singed or burned the sandstone, which they would have represented by these little marks, which we call contact metamorphism. However, since the marks don't exist, that means that the sandstone was there previous. I'm sorry, the sandstone was there after the magma actually originally came up. So again, the intrusion, this is number 4B. The intrusion likely came up before, okay, the other layers. Again, why? Because there's no contact metamorphism between them. Okay, let's go to 5A through C. So here we are, diagram 5, and we see some fossils going on in here. And first question for 5 is letter A. It says, what are the processes involved in the formation of the unconformity? To make this squiggly line, you need erosion and weathering, or weathering and erosion happening somehow when this used to be at the surface. And then a new layer, in this case the sandstone, came down and buried that surface which had been weathered and eroded. Okay, so this brings us to number 5B. List the names of the index fossils from oldest to youngest. So we got this guy here, this guy here, this guy here, and this guy there. So we're going to have to keep in mind what this looks like. So again, we have this guy, this thing that looks like a cornucopia, like this kind of like almost like a claw. We got this thing that looks like an upside down broom, and of course, T-Rex, right? Coelophysis. So what we're going to do is we're going to look up, okay, the names of each one of these in order of 1. This is going to be 1. This is going to be first, second, third, and fourth. And the place that we're going to look these up are going to be in our Earth Science reference tables. And although we have not quite learned about these pages yet, we can still look up pictures, right? So the first picture actually matched this. And that's the first fossil, which we call Elliptocephalia. So for question number 5B, diagram number 5B, Elliptocephalia was first, which was followed by that thing that looked like the claw, which is Valcuroceras, which was followed by the thing that looked like the upside down broom, which is Eucalyptocrinus. And then that is followed by the thing that looked like the dinosaur, right, like T-Rex looking, and that's Coelophysis. So it goes Elliptocephalia, Valcuroceras, Eucalyptocrinus, and Coelophysis. All right, that's moving us to 5C. What is the name of the rock that formed during the Triassic period? Okay, so we need to go back to the diagram for that. So here we are, and we are in the block diagram once more. And the name of the rock that formed during the Triassic period would have been, okay, this Triassic was the time of the dinosaurs, according to the reference tables. So they're simply just asking you, what's this rock in here called? Which what you're supposed to do is you're supposed to match this dot dash pattern with page 7 of the reference tables. So I'm going to go to here, and the dot dash matches with the rock named Siltstone. So that would be Siltstone, and that's the answer to number 5C. So that brings us to diagram 6. Okay, diagram 6, you've got a lot going on in here, but this is actually not the first time we've ever seen this. You actually saw this block diagram in your notes on Friday. And what they want is for you to list the sequence of events from oldest to youngest, starting with the first thing that happened through to the last. So that's what we're going to do. Okay, this is pretty easy. We know from the law of superposition that the oldest layers are always going to be found on the bottom. So I'm going to be like, okay, G is first. So this is going to be number 1, followed by F, number 2, followed by E, then D, then C. Now, notice how these layers are all deformed and they look curvy. All of these layers have all gone through what we call folding. So after you list G, F, E, D, C. Oh, and I forgot letter H in here, my bad. Okay, so D, F, E. Okay, and then D and H are kind of like the same if you look, D and H. Okay, and then C. What you have is folding of these layers. So it goes 1, 2, 3, 4. This is also part of 4, 5. And then number 6 is going to be folding, right? So 6 is folding. And then we have this erosion that took place, but it's been buried. So we call number 7 the unconformity. After the unconformity, the 8th thing to have happened is this limestone in here. And then we had some shale taking place. Letter A is shale. And then at the surface, you always want to make note if anything's getting weathered and erosion. So we're having weathering, you can write in weathering, and erosion at the surface. So I'll repeat that one more time since there was many layers. This is diagram 6, letter A. It's the only question for number 6, and it goes G, F, E, D, C. Okay, and remember D and H are the same thing, so if you want to do D/H and then C, and then you want to say folding and unconformity, which has squiggly line, B, A, erosion at the surface, and weathering and erosion. Okay, all right, let's move on. So here we go, number 7. Number 7 says, number 7A, list the sequence of events by rock name and process name that form the cross section. So this is pretty easy stuff. The first thing you're going to start with is to go all the way to the bottom, and you know that the oldest are found at the bottom, and we have limestone. And limestone's really, you only see a little section over here, and then a little section over there, but don't miss it. After the limestone, we have the bullet shale. We have the New Creek gypsum, the Dunbar limestone, the Erie coal. And then you can see these have all been deformed through folding. So the 6th thing that I would list, number 6, is that you have folding. After the folding, we have an unconformity. That's this squiggly line. So that's going to be 7. Number 8 is your Freeport sandstone, followed by your Gale shale. And then, of course, at the surface, we have weathering and erosion. So there are 10 steps in total. And again, you might have to pause this video along as we go, but it goes limestone, bullet shale, New Creek gypsum, Dunbar limestone. We've got the Erie coal. We've got folding of all those layers. That's why they look warped and curved. Followed by an unconformity, the Freeport sandstone, the Gale shale. And at the surface, we're having weathering and erosion, which is the breakdown of those layers. Okay, or I should say breakdown of that layer at the surface. Let's go on to number 8. Here we go. Oh, my bad. I missed 7A. I'm sorry, 7B. I'll go back one. 7B has this Erie coal form. And this is a reference tables reference, right? They want to know if you know how coal is formed. And if we look right here, coal is found in the ground after you've had plant remains buried and compacted over a long period of time. So the coal kind of gets compressed in the ground from ancient plants, compacted, compressed, and those plants turn into coal. So the Erie coal was created through compacting of ancient plant remains. All right, that brings us into question or diagram number 8. Okay, what do the thick horizontal black lines represent? So this and this is what they're talking about. And if you look, this is basalt flow. It's magma that has come up from the ground. This particular one that says Palisades Sill was a basaltic intrusion. It says igneous intrusion. Whereas this one, this basalt flow, was an extrusion. Since it didn't burn the layer above, that was magma that came up to the surface. So again, these thick black lines, this is diagram 8A. They show you lava or magma flows, which are igneous intrusions or extrusions. 8B, what do the thin whisker-like vertical black lines, they're referring to these guys in here, what do they represent? And it says, oh, I don't know how I just created that. That was cool. But what they represent are places of contact metamorphism, where the magma is singeing, if you will, or burning the rock layers that were already there to change them into a metamorphic rock. So again, that would be contact metamorphism, and that is the answer to 8. Okay, diagram 8, obviously it says right there, but 8B. Okay, so that brings us to 8C. Is the Palisade Sill younger or older than the Brunswick sandstone? How can you tell? And the Palisade Sill is going to be younger than the sandstone it's found within. And the way I know that the sandstone in here, the Brunswick sandstone, existed before this Palisade Sill came in, is because the Palisade Sill burns, it singes. These are the burn marks that you see all here. It singes the sandstone, which means the sandstone had to have been there first to be burned by that igneous rock. Okay, so again, it is younger. How do we know? Because the magma burns it or singes it. All right, hopefully you guys are hanging in there. We're going to go up to diagram 9. So diagram 9, you've seen something very similar to this before when we learned about this, and it says diagram 9A, list the sequence of events from oldest to youngest that form this cross section. Okay. So A is at the bottom. That's going to be first. That's the oldest. So you would list A, and then it goes B, okay? And then you got a little bit of an unconformity in here, but we won't even make note of that. So A, B, okay? After A and B comes C was third, and then D, all right? And then the magma comes through to the surface. So the last thing that would have happened would have been this layer in here, which would have been your igneous rock. So it goes A, B, C, D. And again, since you see all these singe marks, that means that this igneous rock came up last as number 5. Okay, so again, if you need assistance, you just write down A, B, C, D, followed by your igneous rock. And that would be 9, letter A. I don't think there is a B or C for number 9, which makes it kind of easy. All right, so let's go on to number 10. Number 10 asks 3 things, an A, a B, and a C. What is the name of the rock at letter A? Okay. A is where magma has come up, right? So imagine this is magma burning through the rock layers that were there. And what the magma does is where it comes in contact with other rock layers, again, it singes it, and we know through those little lines, which we call contact metamorphism. So sandstone is what's in here. This is all sandstone in here. And the sandstone is being singed by the magma where the magma makes contact. So we need to find a metamorphic rock, okay, which is created from sandstone. So a parent rock of sandstone is made into what? So if we go to the metamorphic rock chart in the reference tables, sandstone, okay, will, when it's hit with lava, turn into the metamorphic rock we know as quartzite. So the answer to that would be quartzite. Okay, so that is question number, let me just go back. That's going to be question 10A, is quartzite. 10B, did the fault occur before or after the intrusion? Now, here's the fault. The fault is this straight line that cuts everything and kind of displaces one layer to go down and the other layer to go up. And they want to know if that happened before or after the magma. Since the magma was cut through by the fault, then the fault is younger and happened after the actual igneous intrusion here. So again, 10B, okay, the fault happened after the intrusion because the intrusion was affected. It was cut in half. Okay, that brings us to 10C. Did uplift, weathering, and erosion occur before or after the fault? Explain. Okay, I'm going to say that it happened after because if you look here, okay, the fault cuts through everything, right? and then you have the wearing down of the surface here. So again, for 10C, okay, did uplift, weathering, and erosion happen to occur before or after the fault? It happened after. The fault happened first, and then things started to get broken down afterwards. Okay? All right, let's go to 11. Moving right through this. So here we go, 11. Did C form, yes, before or after B? So, ready? 1, 2. This burns E and D. These are the burn marks in here. So this is going to be 3, 4, and last to happen, fifth to happen was A. So if you go back, did C form before or after B? It happened before because C doesn't burn B. There's no little burn marks here like that. Okay, if this does not burn B, that means B wasn't there when C came up. So it absolutely happened before. Okay, next question. This is 11B. Are these layers presently above or below sea level? And I'm going to go with below. These probably all happen under the ocean. So imagine the ocean up here. And the reason why I'm going to go with below is because I don't see any type of weathering or erosion that typically happens at the surface. Okay, so like at the surface, like if we go to additional layers, you often have some type of breakdown at the surface, as you see here, like weathering and erosion. And since I do not see any evidence of any kind of unconformities or weathering or erosion or breakdown, like inconsistent, like wobbly kind of layers at the top, I'm going to go, this happened under the ocean. Okay, there's no evidence of weathering and erosion anywhere in this block diagram. Okay, that brings us to 12. We're moving right through. What is line XY called? XY is called your unconformity. So again, they are highlighting this in here, this wiggly line. Again, this is called your unconformity. That is 12A. How does it formed? You have erosion, and weathering and erosion, which was buried by a new layer. And if you're like, yo, you lost me on that, Corso, the definition of unconformity can be found on the front page of the lab or your notes. All right, number 12B, list the epoch and period in which the 3 layers of shale form from oldest to youngest. Okay, so there's 3 layers of shale. This is one of the layers. This is a second layer, and this is a third layer in that order. So this is oldest. This is the next layer, the middle layer, and this is the last layer of shale. And they want to know basically during which time periods these 3 layers of shale formed. So I'm going to go and look up these 3 fossils. This guy, this guy, and this guy. We've actually seen the first 2 already in this lab. This guy we're going to have to find also in our reference tables. So I'm going to go to back to my reference tables. I'm going to turn to page 8 and 9, and I'm going to start looking for those guys at the bottom. And we already saw elliptocephalia from earlier, right? That's why it's still highlighted. We say Valcurocirrus is there, but let's erase that one and that one. We're going to go to Dicelograptis now for letter K. So we got A, D, letter K are our 3 fossils. And they wanted to know when they were created. So you're actually going to have to find their letters on this chart on page 9. So we got A is here, D is there, and K is there. The only thing that stinks about this is pages 8 and 9 in the reference table is supposed to be used together. So I'm right here is the bottom. If you look, this gray shaded area is the bottom. I'm in the first box up and then the second box up in the middle towards the top. And they want to know the time periods. So I'm just going to go back to page 8. First box up happened during the Cambrian period. So it's the middle of the Cambrian period. This is when this guy was created, letter A. Okay, and then it goes, when was D and K? And D was a little bit more towards the middle of the Ordovician. So we got middle Ordovician, and K was towards the top, which was still Ordovician, but it was the late Ordovician. So for this question, you would put middle of the Cambrian, middle of the Ordovician, and late Ordovician, and that would be fine. Okay, and those were the time periods, okay, for each of those fossils. They also actually asked for the epoch. The epoch, okay, you don't, is the late middle and the middle. So that's all included in the answer. Okay, so that was 12. Let's go on to 13. So let's get back to our block diagrams here. And here is 13. And 13 asks about, let's see, 13 asks about letter A. During which geologic period were layers 1, 2, 3, and 4 deposited? They used Roman numerals, so don't get confused there. And it says 1, 2, 3, and 4. So that's these guys in here, 2, 3, and 4. And I'm going to be looking up this snail guy, this guy, and this guy in my reference tables. And that's going to help us with time periods. So I'm going to jump back to my reference tables. Let's erase some of the existing stuff that we have on here. And they need a time period. And again, I'm going to be looking for, if we think about it, it was phacops. That was one of them. Yeah, let me just turn my page so I can get my picture up for number 11. Oops, sorry, not 11. That was number 13. So we got this guy. Oh, no, I made a mistake. No, I didn't. It was this guy, the snail guy, and it was the guy who kind of looked like a tree, which I believe is listed on the bottom of this page. That would be this. So it's letter Q, the Naples tree. So again, they want to know what time period phacops, Centrocerus, letter F, that looks like a snail shell, and the Naples tree existed. So what letters are that again? Q, F, and C. Time period of Q, F, and C. So let's just erase what we had from previous questions here. Q would be right about here. F and C. Oh, this is beautiful. They're all in the same time period. You see this line here and this line here, right? If you look at these two lines, that's 1, 2, 3, 4, the fifth box up from the bottom of the chart. And I'm going to go here, 1, 2, 3, 4, 5. The time period is the Devonian. And again, it says period at the top. That's why I know I'm using that column. So the time period in those three, for those three fossils were created during the Devonian. So number 13, letter A, Devonian. Okay, letter B for 13. Why is elliptocephalia located everywhere within layer V111, which is layer 8? And it's why is the elliptocephalia located everywhere within this layer? Let's see. Hold on, let me go back to the block diagram. Elliptocephalia, why is it located? Okay, here. You know what? It would be located here, okay, in the shale. But the reason why it's not located everywhere, I think that's supposed to actually read why is the elliptocephalia not located everywhere, is because in this layer here, it's magma, and magma destroys fossils. Fossils really can only exist in sedimentary rocks. So I think that question was actually written without the not. Again, fossils can only exist in sedimentary rocks. The reason why it would not be located everywhere within that layer is because magma will destroy fossils. Okay, so that is number 13, B. All right, block diagram number 14. So here we go, guys. We are all the way up in our report sheet to this point. If you're starting to kind of get wearing thin, because I've been going on now for about a half an hour with this lab, pause it by all means. You can always come back to it tomorrow. You have 2 days to do this. So definitely give yourself a break if you need to. Just, record the time that you stopped, and then you can come back to it at any time in YouTube, right? So let's go to our block diagram. We were up to 14, and it says, number 14, in box B, so here's box B, okay, state the names of the 3 rocks layers from oldest to youngest. So I've taken a look here, and the oldest is most definitely going to be shale. And the reason why the shale's on top is because they've all gotten warped and curved around. But if you kind of look at where they're not so curved, shale is definitely on the bottom in here. So it gets curved up in here, but it goes, shale is definitely going to be the oldest, okay? And then the next oldest is going to be the sandstone. And the least oldest, or the most recent out of the 3, is going to be conglomerate. And if you're like, where are you getting these names from? Shale, sandstone, and conglomerates, all rock names can be found if you go to page 6 and 7 of the reference tables. So that matches the shale, right, which was the first one. The sandstone matches this one up here. And of course, then you got the conglomerate, which is up there. Okay, so 14A is shale, sandstone, conglomerate. And then it says, let's see, rock. In box C, state, that would be this box here, state the names of the 2 oldest rock layers from youngest to oldest. So youngest and oldest out of the shale and the conglomerate. The youngest one is going to be the conglomerate, because if you look here, conglomerate is on top of the actual shale. Okay, it just doesn't look like it in here because these have been folded, and then they also have been faulted and shifted. All right, we're almost to the end, guys. So I'm going to turn the page here, go back to our block diagram, and we're going to go to 15. Question number 15 says, state the entire sequence of events that form this cross section. Okay, there's a lot going on here, but remember, we have some tilting, we have some cross cutting, we got an intrusion, or actually this is extrusion right here, but this is how it should be listed. You ready? Okay. Start with layer G. G didn't burn F, therefore G was there first. And after G, it goes, all right, which is obviously layer G is that magma. Then came some shale, okay? And if you notice on the top of the shale layer, you have this squiggly line, which is going to be number 3, your unconformity. So first you say G, then F, then unconformity. After that, the 4th thing to occur was the sandstone at E, so letter E. After the sandstone is going to come your conglomerate. That's going to be your 5th. Okay, what's going on here is that, I almost forgot, all these layers, the 6th thing to have occurred was tilting. So all these layers were tilted. And then they were all offset and like they shifted off of one another. Like you can see the shale doesn't match up with the shale here because of this fault. So the 7th thing to have happened was your fault. Now, magma cuts through all of it. And the reason why I know H is number 8 is because H cuts through it all, but it doesn't burn C, which means C, B, and A came after the fact. It was like this bottom half in here was all first. And then the magma burned through, and then C, B, and A. And then at the surface, you're getting weathering and erosion, which if it gets buried, it'll become an unconformity. So weathering and erosion. There you go. All right. Couple more to go. So that is going to be the answer to number 15. That is letter A. There's only one letter for 15, so 15A. So let's go to diagram 16. Layer E must be older than how many years old? So E is got to be older than this fossil. So we got to find the age of this fossil using our reference tables. So let's go back to pages 8 and 9. Go on the bottom. We're going to look for that fossil that look kind of like this. It's Cystophyllum. So letter U. Let's get rid of some of this old writing in here. So U can be found, hold on one second. U can be found right here. So I'm 1, 2, 3, 4 boxes up. I'm just going to go across to page 8 now. So let's go across to page 8 and I'm 4 boxes up. 1, 2, 3, 4. So here's the age. It's got to be older than about 444 million years. If you go to the top of this, it tells you these are all in millions of years. So the answer to 16A, it would be older than 444 million years. Okay, 16B. Layer A most likely formed during the beginning of what period? So layer A most likely formed in the beginning of what period? So here's A. And A is a period of time after the dinosaurs. So you see the dinosaur bones are all in here, like that goes up to that guy. So what I'm going to do is I'm going to find that guy in my reference tables. We've looked at him before. It's Coelophysis, which is letter L. And letter L, right, falls into right here. and the dinosaurs stopped where the line breaks and stops. So from the top of my chart, I'm 1, 2, 3 down. If I need to know the name of the period of time, I'm going to come back here. 1, 2, 3 down. That must have been sometime after the Cretaceous period. So after the Cretaceous ended and you had the extinction of dinosaurs, okay, that is where other things happen, after the dinosaurs. So again, I would say for 16B, A probably happened. So A most likely formed during the beginning of what period? So probably anytime after the Cretaceous. All right. So last 3 or 4 block diagrams here, 17, 18, 19, 20, last 4. So here we go. Number 17. 17 says, 17A, is the fault older or younger than the intrusion? The fault is under the intrusion. Remember that the intrusion is this in here. So since the fault is underneath the magma, then the fault is older, okay, than the intrusion. Okay, and again, the fault doesn't go through the intrusion. Therefore, if the intrusion goes over the fault, the intrusion was the most recent. So the fault is older. 17B, what type of rock likely exists between the layer of shale on the right side of the fault? And here's the right side of the fault, and what kind of layer probably exists between the shale. So let's find the shale. And what exists underneath that? Well, if you match this shale in here with this shale, this and this belong together, right? Whereas this and this belong together, okay? What's underneath this, if you look on this side, is limestone. So this had a matching limestone that the bricks should have been drawn underneath this section here, but they're not there. So the answer to that would be limestone. So 17B, limestone. Okay, let's get to 18, 19, and 20. So 18. 18A, did the Glossopteris live before or after the eruptions that formed the lava flows? Okay, so Glossopteris, let's see where Glossopteris is in here. So this is, sorry, that was 19's question. Number 18A, what processes likely occurred between the formation of the intrusion at 7 and the layer 4? So between 7 and 4, what happened? Here's 7. This is magma burning through. And then there's 4. And you see this squiggly line in here. And they want to know, what is this, basically? What happened? And there was probably a whole bunch of stuff in here that got weathered and eroded and broken down before layer 4, the shale, came in and buried it. So the answer to question 18A, you had some type of weathering and erosion that took place at this unconformity before it was buried by the shale or layer 4. Okay, 18B, what is the name of the rock that will likely form where layers 7 and 8 meet? So they want to know 7 and 8 meet right along this border. Okay, what kind of rock forms when magma burns? Conglomerate. So I'm going to look for a metamorphic rock, okay, a contact metamorphic rock that is formed when this magma all in here burned this rock in here at the border between them, or the interface. So what rock comes from conglomerate? So we're looking for a parent rock situation on the metamorphic chart. So let's go to our metamorphic chart. That's going to be right in here. And what rock comes from conglomerate? Metaconglomerate. So the answer would be a conglomerate when metamorphosed becomes a metaconglomerate. So 18B, metaconglomerate. All right, last 2. Diagram 19. Did the Glossopteris live before or after the eruptions that formed the lava flows? Explain. Okay, so I got to go look at the diagram. This is 19, and we got Glossopteris, right? And the Glossopteris fossil likely lived before, okay, before the Glossopteris fossils, because they are beneath the lava flows. So if you guys see, like, the Glossopteris fossils are all in here, since this whole layer which contains those fossils are beneath the lava flow up top, that means that they're older. Okay, the law of superposition states that the deeper the layer is, the older. So this came in after this. And then it says 19, number 19B, or letter B, what process likely occurred in this location but is not reflected on the diagram? Yeah, they kind of missed something important on this diagram. And what they missed on this diagram is the fact that since this layer was here before the magma came up, that as the magma came up and it hit this layer, that there should have been some contact metamorphism all in here. So number 19B, 19B, if you will, okay, there should be, you should write there should be contact metamorphism lines drawn between, you could just do that, between the sandstone and basalt layers. Okay, all right, and that brings us to diagram number 20, 20A. Okay, 20A says, why do you think the Queenston shale is more worn away than the sandstone? So why did this break down so much more than any of the sandstones? And the truth be told is that shale, if we look at the reference tables, shale, which is here, is made up of clay, whereas sandstone consists of sand. And if we look up sand versus clay, sand is made of quartz, and it's a much more durable, long-lasting type of material. So sandstones are definitely a harder rock than shale. Shale is much softer, it breaks down much easier. So again, we can kind of see that in the cross section. All right, last but not least, question 20B. What is the name of the youngest sandstone shown in the cross section? They just want you to find which sandstone is closest to the top. So this is water. This is dolostone, shale, limestone, sandstone. So 20B, the youngest sandstone would be the Thorold sandstone. So that brings you through all the cross sections, which if you go back to the original lab, after you're done filling out the cross sections, they ask you some questions. Question number 1, describe the principles of superposition. That's in your notes. So I will make a little note for you to find in your notes. Number 2, how can older rocks be found on top or in the top of the cross section? They can be found on top of the cross section if you've had some type of folding or faulting. Again, we can see that that has happened in some of these layers. There was one particularly in the beginning of all these cross sections where we can see that the folding really made, like in here, the folding made this deep layer come to the top. So again, folding and faulting can make that happen often. Number 3, why is an igneous intrusion younger than the rocks in which it is found? Magma can't intrude and burn things unless there was something already there. So like this is an extrusion, that's not a good example, but this here is an intrusion, right? So in this question, they say, why would this magma be younger than the rocks in which it's found? And the answer is, again, because unless you have rock layers there, the magma has nothing to intrude upon. Okay, you must have the rock layers there for the magma to burn through. That's what an intrusion means. Magma burn through and burn rock layers that were already there. Okay, so that brings us to 4. Explain why the age of a fault or fold is younger than the rocks in which it's found. Again, you cannot tilt, fold, or even cut through rock layers unless the rock layers already exist. Number 5, describe the process by which an unconformity is formed. Guys, that can be described right here. If you guys go back to your first page of your lab, the introduction, or your notes, unconformity is listed right there. And then your final question here, what guidelines are used in determining the relative ages of rocks and events in geologic cross sections? So I need to scroll back out. Where do we go here? So I'm at 600%, hang on. And basically what they want you to do for this last question is just describe, like, tell me how the law of superposition and the law of cross-cutting and the law of original horizontality all help us determine how we figure out what comes first, what comes second, what comes third, what comes fourth, and so on. And I would probably just say something along the lines of the deeper rock layer is, okay, the older it's going to be. If something cuts through or burns through rock layers or tilts or folds rock layers, all those things are going to be younger than the rock layers in which they occur. Okay? So I'm hoping that you guys, were okay through this whole lab. It was about 50 minutes long, so hopefully you broke it down into 2 sections. And of course, as soon as you are finished, please submit it to me. And I think that's about it. All right, guys, I will definitely check in with you. Make sure you come to your meetings and check in with me. And have a great day. All right, bye-bye.